Have you ever just stared at a page full of numbers and thought, nope, I'm just not a math person? I mean, we hear it all the time, right? This idea that you're either born with a math brain or you're not. But what if I told you that whole idea is basically a myth? Well, that's exactly what we're going to dig into. So this is the big question, or isn't it? Is math ability some kind of innate talent, something you're just genetically gifted with? Or is there something else going on entirely? We're going to look at the sociology, the psychology, and even the cognitive science to figure out what really makes someone good at math. Okay, so before we can bust this myth, we have to understand where it even comes from. Why is this idea of being a math person so powerful and, so widespread? Turns out it's got really deep roots in how our culture thinks about things like truth and intelligence. To get to the bottom of this, we've got to look at how we view math itself. And this Reddit user really hits the nail on the head. We tend to put math on this pedestal. We see it as the ultimate source of pure, objective truth. 2 plus 2 is always 4. It's clean, it's logical, it feels kind of untouchable. And that thinking leads us right to the next big assumption. See, if math is this pure, abstract truth, then the ability to understand it must also be a pure, innate quality of your mind. It creates this invisible hierarchy of intelligence where the people who get math are just seen as naturally smarter than everyone else. And that brings us to another huge piece of the puzzle, the supposed link between being good at math and having a high IQ. We've all seen those articles, right? The ones claiming that math and physics majors have the highest IQs on campus. It just seems to confirm this idea that math is only for a special class of geniuses. But when you actually look closer, that whole link starts to get a little shaky. Yeah, not so fast. As this Redditor found out when they actually dug into the data, a lot of these claims kind of fall apart. They aren't usually based on actual, proper IQ tests. Nope. A lot of the time, they're just using SAT scores. And what do SATs measure? Well, they measure what you've been taught and how good you are at taking tests. These are skills you learn over time, not some fixed, unchanging intelligence you're born with. So the evidence for this super tight link between math and IQ? It's flimsy at best. Okay, so if it's not some magic math gene or genius-level IQ, then what does it actually take to succeed? Let's switch gears and look at what the research says really matters. This is from a really fascinating study led by a researcher named Ku Moriyama. And the findings? They're crystal clear. Sure, IQ might have something to do with a student's starting point in math, but it does not predict how much they'll improve over time. You know what does? Motivation. The students who were genuinely interested in the subject, the ones who believed that hard work would pay off, those were the ones who improved the most, no matter what their initial IQ was. But look, just wanting it isn't the whole story. Especially when you get to higher-level math like in university, success also depends on developing some pretty specific ways of thinking. A 2016 research paper dug into exactly what those skills are. The first key skill is what psychologists call fluid intelligence. Now, this isn't about what you've memorized. It's all about how you think. It's your ability to see patterns, to solve brand new problems you've never seen before, and to think abstractly. All of those are absolutely crucial for tackling complex math. And the second skill is called cognitive reflection. You know that feeling when you jump to an answer that just feels right, but turns out to be totally wrong? Well, cognitive reflection is the ability to hit pause, to question that first gut instinct, and to think a little more deeply. It's about not just accepting the easy answer without double-checking your work. So what this study concluded was that both of these things, fluid intelligence and cognitive reflection, are major independent predictors of success. But here's the best part. These are not fixed traits you're born with. They are cognitive skills. And just like any other skill, you can develop them and get better at them with practice. So we've got motivation, and we've got these specific cognitive skills. But there's one more piece to the puzzle, and it's all about mindset. What does it actually feel like to think like a mathematician? I absolutely love this quote from Stanford mathematician Dr. Keith Devlin. It just completely flips the entire subject on its head. Forget about cold, boring formulas. Think drama. Think characters, plot twists. For a real mathematician, all these abstract concepts aren't just symbols on a page. They're like characters in a story that's still unfolding.
So, how do you tune in to this math soap opera? Well, first, you have to get invested in the drama. You have to actually care about the patterns and the relationships between all the numbers. Second, you have to believe in the characters. You have to treat abstract things like algorithms and parabolas as if they're real things with their own personalities and behaviors. And finally, you have to follow the plot, which means understanding that it takes real, focused practice to see how the whole story comes together.
So when you put it all together, you realize this whole I'm bad at math idea is built on a pretty shaky foundation of cultural myths and some misunderstood science. And the power to change that story, well, it's completely in your hands. So let's wrap this up. What does it really take? It takes the right mindset, seeing math as this dynamic, unfolding story, not just a list of rules. It takes motivation, finding a real interest in the subject itself, not just in getting a good grade. It takes developing those key skills like fluid intelligence and cognitive reflection. And finally, it just takes practice, a lot of it. You don't become an Olympic athlete overnight, and you don't get good at math overnight either. It takes diligent, regular practice. I want to leave you with this one last thought. We're so used to thinking about math ability as this fixed thing, like your eye color. But what if all the evidence is pointing to something completely different? What if being good at math isn't something you are, but something you decide to become?